Hi, Assalamualaikum. My name is Muhammad Iqbal Arif bin Hadi. So, I'm from Group 6 and we are going to present about our Transform Circuit project. So, our group is consists of four members, which is Muhammad Fadl Hazim, Muhammad Haziq Zikri, Muhammad Azfar Nabil, and Muhammad Iqbal Arif. So, as an introduction, electrical circuits with RLC loads powered by a non-sinusoidal AC source are example of real-world scenarios which is harmonic is introduced into an electrical circuits. So non-sinusoidal source such as those generated by components, for example, power electronics are introduced complexities to the circuits due to its multiple frequency components. So the aim of this project is to use Fourier series to analyze the circuits by calculating the electrical parameters such as current in each branch, voltage in each node, and also power in a selected load. So the Fourier series will allow us to break down the sinusoidal waveform into harmonic components and address the of the component impact of the harmonic to the circuit. So this project is divided into two parts, which is part one of manual calculation. So the manual calculation is by using Fourier series to determine the circuit parameters, which is the current in each branch, voltage at each node, and also power in a selected load. So part two of the simulation is software simulation, which is we're going to simulate the circuit using software to obtain the same parameters as the manual calculation. So then the result of this both calculation will be compared.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asman bin Zahri and my metric number is DE220170. And now we explain about our circuit. So for the first, we use a multi-sim software to create the circuit. So for the first, we use this function generator to Henry inductor, 0.5 farad capacitor, 2 ampere current source, and 10 ohm resistor. So for the first, we need to find a power average. So this is our power average, which is 9.96 watt. And then for our function generator, the frequency we set 0.5 Hz. Duty cycle 50% and amplitude is 10 voltage peak. And next, so for our oscilloscope graph, this is our graph. And for time-based scale, we use 1S per division and channel A 10 volt per division. And then I continue for Fourier. So for Fourier, we use a frequency resolution is 0.5 Hz. Number of harmonic is 5 and stop time for sampling this stop is 1. Sampling frequency is 30 Hz. And then we go to output. So this is our output for this circuit. First, current for C1, current for L1, and current for R1. Also, voltage 3 and voltage 4. And then we save, then we run. So this is our result for the Fourier. This is oscilloscope result. And then is for V3. This is our V3. And this is our harmonic for V3. We use 0.5, 1.5, and 2.5. Next is for V4. This is our frequency for phase and magnitude. Also for current for C1, current for R1, and current for L1. So we can get data from here, this harmonic. Okay. That's all from me. Thank you.
Hello, my name is S1G6. We travel E22006. So I'm going to present about the manual calculation. So first of all, we need to find the V indication. So for the angular frequency, we use 2 pi f, which is f is 1 over t, which is 2. So 2 pi over 2 is pi represented. And next is n equal to 1 over t integrate and limit to n 0, so then we get 0. Also for n, 2 over t integration of ft cos n omega t, we limit t and 0, we get also 0. And for bn, 2 over t integration of ft sine n omega t dt, and we get 20 over n pi 1 minus negative 1 power of n. So we get the equation is begin t equal to 4a equal to 4a over n pi in sine n by t. So the amplitude for n harmony is v equal to 4 times 10 over n pi equal to 40 over n pi. So for the first three harmonic, for n equal to 1, we got 12.73 volt. For n3, we got 4.24 volt. And n5, we get 2.55 volt. So the impedance for each harmony is exactly letter is the 2 n pi. For pendant for the capacitor is 1 over j n pi, and 0.5 we get di over n pi. And for the ZLC, get negative 2 over 2 minus 1 over n squared. And Z total equal to ZLC plus ZR. So for the harmonic n equal to 1, we got ZLC is equal to negative 2 ohm, ZT equal to 8 ohm, and I get 1.59. For harmonic n equal to 3, ZLC is negative 18 over 70 ohm, ZT is 8.94 ohm, and I3 is 0.0474 ampere. And for the harmonic n equal to 5, ZLC is 8040 over 49 ohm, ZT is 8.8498 ohm, and I5 is equal to 0.284 for each branch. So node A at begin, node B between R and LC parallel branch, voltage voltage for node A is equal to input voltage. So for the harmonic n equal to 1, voltage at node B is 15.9 volt, and voltage at node A is 12.73 volt. The harmonic for n equal to 3 is at node B is 4.74, and at node A 4.24 volt. Harmonic n equal to 5, voltage at node B is 2.84 volt, and at node A is 2.55 volt. So the equation is Bell is equal to 15.9 sine pi t plus 2.72 sine 3 pi t plus 2 and plus 2.84 sine 5 pi t, and so on. So power dissipated in resistance is, when n equal to 1, power is 25 128. watt, and equal to 3, we get 2.25 watt, and equal to 5, we get 0.806 watt. So for the power total is 25.28 plus 2.25 plus 0.806 equal to 28.35 watt. And for the average, we get 9.33. That's all for me. Thank you.
Okay, hi and hello. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fadilan Hazim bin Karya Fazilah, and my metric number is DE220105. I will present to you our group discussion. Okay, the result of manual calculation and simulation using multisim for the given circuit are compared in the table below. The comparison includes parameters such as voltage, current, and average power for harmonics, which is N1, N3, and N5. Okay, this is the table. The parameter voltage at node A, voltage at node B, current, average power. And this is the result for our manual calculation and simulation for N1, N3, N5. Okay, next, analysis of result. The voltage analysis. There are relative minor difference between the voltage values at nodes A and B obtained by simulation and generating. This variation results from rounding during manual computation and the multisim simulation is precise limitation. Current analysis. The current value across the resistor R1 for all three harmonics N1, N3, and N5 show consistency between manual and simulation result. Minor deviation are attributed to the assumptions in manual impedance calculation and the discretization in the simulation. Okay, for the power analysis, the average power calculated manually, which is we got 9.33 watt, and simulated we got 9.96 watt, are very close. The small percentage difference reflects the robustness of the Fourier analysis is inaccurately estimating power in periodic signal. Okay, for the error percentage, the error percentage are minimal, indicating high accuracy between the manual calculation and simulation result. However, higher harmonics exhibit slightly higher error due to complexity of accurate impedance and waveform representation for high-order terms. The table below summarizes the error percentage for each parameter compared between the two methods using formula. Okay, for the error percentage formula is manual calculating value minus simulation value divided by simulation value. Okay, this is the table we got for the value of percentage error for N1, N3, and N5. Okay, that's all from me. Thank you.
So as conclusion to this project, the analysis of and simulation of this circuit were successfully conducted. The manual calculation using Fourier series provided insight to the circuit's behavior, including by calculating the current, voltage, and also power. So this result is validated through the software simulation using uh, multisim, and the result is compared and which produce consistent outcome and confirming the reliability of both method. So for the series analysis in non-sinusoidal source electrical circuits, and accuracy of the simulation tools is proof in this project. So that's all from us. Thank you.